Hey everyone, and welcome to Dr. Abu RTN Academy channel. Today we are going to discuss part 6 of the sets and the probability of the biostatistics. In this part 6, we are going to discuss the axiom of Kolmogorov. The axioms of Kolmogorov. Kolmogorov is the name of statistics scientists. So just a name. Axiom means the principles, the rules, the basis. Okay, so this axiom of Kolmogorov of probability, these are some rules or basic rules which was set by Kolmogorov for the probability. 3 principles or 3 rules, and some people divided some of them into sub rules and they arrived to 5 rules. So it differs. You'll find in some books that the axiom of Kolmogorov is 3 principles or 3 axioms. In some other books you'll find them 4, some other books you'll find them 5. But the principles are 3, and then we have subdivision of some of these axioms. So it could be 4 or 5, but all of them are talking about the same 3 principles. So as we can see at the bottom of this page, axioms of probability, these are the 3 axioms or the 3 principles, the 3 rules, and we have already came in touch with all of them, that all the probabilities are between 0 and 1. You will find in some books they said, okay, the probability of something which is impossible, it is 0. The probability of the universal set is 1. But at the end of the day, it is the same principle. All the probability cannot be more than 1 and cannot be less than 0. So the probability of any event A, for example, it is greater than or equals to 0, and it is less than or equals to 1. So you will never ever find any probability which is less than 0 or more than 1. This is the first principle or the first axiom which we have here. Okay? The second axiom is necessarily true, which is what we call it, and the necessary false, what we call it. We have taken these 2 provisions in the last slide, in the last video. So, necessarily true, we have said it has a terminology which is certain. Something which is assured 100% it will happen. Necessarily true, okay? And necessary false, we said this is impossible. Okay? So necessary true, it must happen. So the probability of something which is must happen, necessary true, is 1, because it must happen. Okay? So if I said that the probability of throwing a dice and having a number between 1 to 6, 1 or 2 or 3 or 4 or 5 or 6. So this probability it should be 100%, because dice doesn't have 0, doesn't have 7. It has only from 1 to 6. So the possibility of having a number between 1 to 6 is 100%. Okay? The possibility or the probability of having number 7, which is necessary false, it cannot happen by throwing the dice, it is 0. So this is false. This is the second axiom. The third axiom is the disjunction. What does this junction mean? We have taken it already in the previous video. We said the probability of A union B equals the probability of A plus the probability of B. And we said, okay, the probability of A, for example, is 0. If A, even as per the example which we have given in the previous video, 0.4. The probability of B, 0.5. So we have said that the probability of A union B equals 0.4 plus 0.5, because A union B means A and B. So any of them happening of A or happening of B, it will be true. Okay, so it will be 0.9. But we said this is subject to there is no intersection between them. Okay, there should be this joint. This joint means that A is here and B is here, A and B. If this is A and this is B, it will not be true. We cannot use probability of A plus probability of B. If they are disjoint, it will be true. If they are disjoint, it will be true. Okay? So what will happen if we have intersection? If we have A and B, they are intersecting in this area. So what will happen? How we can treat this? We say that this rule is applicable for the disjoint set. If we have two sets, A and B, and they are disjointing, there is no intersection between them. So if there is possibility that they will be intersecting, so we have to use the general formula. General formula for disjointing, it is applicable whether they are disjoint or they are not disjoint. So we can use it in all the cases. So the general rule or general formula, the probability of A union B equals what? Equals probability of A plus probability of B minus probability of A intersect B. We have taken this already in the last video, but we repeat it again. So if I have the probability of A equals 0.4, probability of B 0.5, probability of A intersect B 0.2, so the probability of A union B in this case, okay, it would be probability of A, the first one, plus the probability of the second one, probability of B, minus the probability of the, not the union, the probability of the intersect of them, which will be probability of A 0.4 plus probability of B 0.5 minus the probability of B intersect A intersect B, which is minus 0.2. So 0.4 plus 0.5, 0.9 minus 0.2 equals 0.7. This will be the probability. Okay. So what if A and B are disjointing like this? A and B, they are disjointing. There is a space between them. There is no intersection between them. In this case, the probability of A intersect B is 0 because nothing here. It is impossible that we'll have anything A intersect B. They're not touching each other. So the probability of A intersect B is 0. So we can go directly and say the probability of A intersect B equals 0, eliminated, 0. So the answer will be probability of A plus probability of B, which is this one. Okay? So that's why I said here, this is a general formula. Sorry, this is a general formula which we can use in all the cases. Probability A plus probability B minus probability A intersect B. Okay? If we don't have intersection, they are disjointing, we can use this special formula for the case of disjointing, where we don't have any intersection, for the case of disjointing. Okay, A and B are disjointing, so we can use this formula. But if there is any intersection, we can use this one. Even if there is no, we can use this one, and the probability of A intersect B, it will be 0. Okay, that's why they are calling it the general formula. And as I mentioned, there are many other forms of writing the axioms of probability of Kolmogorov. So this is another form or another shape of it. Axiom 1, the probability of A is greater than or equal to 0, and it is less than or equal to 1, which is the same. The probability of the universal set, which is everything, something which is assured. This is called the certain. Okay, we can delete this one and write the certain. Certain cases, certain. If we have a certain case, it will be 1. If we have something which is impossible, it will be 0. Axiom 3, the probability of union AI. AI means A1 union A2 union A3, or probability of A union B, or A1 union A2 union A3. So this one can be expanded, the like probability of A1 instead of AI. We put I first time 1 union A2 could be union A3, and so on up to infinity. We can write any number of unions. So the probability of A1 union A2 union A3, or A union B union C union D, whatever, okay, it will be equals to the probability of A1 plus the probability of A2 plus the probability of A3, subject to, again, that they are disjoint. They are disjoint. Okay, if they are, these are disjoint, okay, there's a space gap here, there's no intersection. But if they are intersecting, there's a special case. We have to say minus probability of A intersect B. Okay, so as we can see in axiom 3 here, if I have the probability of A1 union A2 union A3, so I can write it, the answer will be, because this is probability of unions, so it will be probability of A1 separately plus the probability of A2, okay, probability of A1, probability of A2, probability of A3, and so on. So probability of A2, probability of A3, all of them, we have to sum or add all of them together, okay? So I can write this one to avoid complication and have lengthy formula. And instead of writing the probability of A1 union A2 union A3, I can say the probability of AI. What's the probability of AI? Probability of union AI. So I have to add here union. And what is this I? I can take any number. Okay, let's write it again. Probability of AI. So what's AI? Union. Okay, so what is this I will take? I will take any number. I could be starting from I1, which we have here. I1 here. Okay, I2, I3, up to infinity or any number. Okay, so the probability or union of AI, and I will take from I equals 1 up to infinity. Okay, so it can be as probability of AI, the probability of union of AIs, okay, where this I will take any number, could be I1, like here, A1. If I put I by 2, it will be A2, I by 3, it will be A3. If I replace I by 4, it will be I4, and so on, up to I replace it with the infinity. So the probability of union AI, where I could be I1, from I1 up to infinity, could be from I5 up to I10. So if I said I5, I start from 5 up to 10, I have to replace it here, from I equals 5 up to I equals 5, 6, 7, and so on up to A10. Okay? Okay. So here, the way it is written, probability of union AI. So it is union of all AIs, A1, A2, A3, A4, A5, A6, A7, whatever. But the starting point, and shall I start from 1 up to infinity, or from 5 up to 7, or from 13 up to 29? This will be determined by the I. The starting point of I, it starts from 1. So I starting from A1 union of A1. Okay? If I put I5, I have to start here from A5. Okay, union, the starting point is I equals 1, and the ending point is infinity. Okay, So this is the question. The probability of union AI, the probability of union AI, where I is starting from 1 up to infinity, will equals to the probability of each individual one. Probability of A1 plus probability of A2, probability of A3. So it will be the sum of the probability. Sum of probability of all A's. Sum of probabilities means that the probability sum of probability A1 plus probability A2. So I can put it probability AI, but also I have to define I. I should be the same thing. I equals 1 to infinity, same as this one. So here I equals 1, I equals 1. Up to infinity, up to infinity. If here we start from I equals 5, I have to start from I equals 5. If I end with I equals 15, I have to end here with I equals 15. So both should be the same thing, okay? I hope this one also is clear. In this slide, we'll discuss how to represent or draw or represent the probability using Venn diagrams. We used in the set to write set A and set B, set A and set B, and what any number, whatever, 3, 7, 5, 8, 13, 1, 2. So we used to present them in Venn diagram. But here we are not representing the set, we are representing the probability itself. Probability is a number between 0 and 1. So there was many suggestions how to present them in the same way of the Venn diagram. So we said we represent them by area. So similar, just let me erase this one to make it clear. Okay, so similar to the representation of the sets, but the figure representing an event, okay, has an area that is proportional to the event. So in this case, the figure representing the event, it will has an area, and this area will be a proportional to the event. So the proportion of any event is 100%. Okay, all the possible options. Okay, so the proportional of having numbers when I throw the dice from 1 to 6, it is 100% because I don't have another choice. If it is 1, it is 1 over 6, 2, 1 over 6, 3, 1 over 6. If I sum or add all of them, 1 over 6 plus 1 over 6 plus 1 over 6 plus up to the last one, so I'll end up with 1. So the total probability of the event is 1. 1, complete 100%, you can say, or 1, okay? 100%. This is the total area, okay? So, but what is the possibility of having number 3 only? It will be 1 over 6, okay? So I can have the area, for example, the area here, which represents 1, and have only 1 over 6. I can split it into six areas, and it will be 1 over 6 only. I take portion of it. If I have another one, say for example, I said the probability of 1 and 6, for example. So 2 over 6. So I have another area to be added. So if I set the probability of odd numbers will be 1, 3, and 5. If I throw the dice, it will be 1, 3. So 3, and the total possible ways are 6. So 3 over 6, which is half. So it will be another section. So I have 3 sections. Okay, and so on. So it will be represented as area. So if I say the probability of event A equals the area which represents A. The probability of a certain event, which is 100%, is 1. All the possible options. Okay? So if I have head and tail, what is the probability? If I throw a coin or flip a coin, what is the possibility that I'll end up or I'll get head or tail? It is 100% because I don't have another option. The probability will be 1. The head probability is 0.5. The tail probability is 0.5. So the possibility of having head or tail, it will be 1. 0.5, we just took it in the last slide, plus 0.5. The probability of having head union tail equals the probability of head union or plus probability of tail. So it will be 0.5 plus 0.5 equals 1. Okay, I hope this one is clear. So the total or the certain probability or the probability of the universal sets, the overall probability, it is 1. Okay, so the probability of all possible ways, it is 1. But what is the probability of the favorable characteristic which we are looking for? The criteria or the selection which we are looking for. Okay, this will be part of the 1. It could be 1/6, it could be 2/6, or it could be half, it could be any number, but it is between 0 and 1. It could be 100%, could be 1, could be 0. Okay, this is what we are going to represent. So the probability of certain event is 1. So the probability of an event A equal the area of A divided the area of certain, which is called here in this example area I, which is this one, the probability of I. So we are not representing it 20 centimeters square or 35 meters square. No, we are taking it as 1. So the total area of this square is 1. Okay, for simplicity. So if you have 0.5, you have to highlight half of this area. Okay, just let us erase this one. So the area always will be 1. So if I have probability of certain thing or the universal, you call it PS equal 1 or PI equal 1. It's up to the terminology which you are using. Here in Debrecen they're using PI, so we can use PI equals 1. The total area here. Let us use different color. Okay, the total area here is 1. So the probability of tail, for example, equals half. So if I want to represent it here, I first to erase all this and draw it again. Let me draw it again. It will be half. So I have to shade half of the area. So here probability of tail is 0.5, half of the area. So we are representing it by area. I hope this one